learners. Today we're going to talk about bitwise operators in C. And I'll start off with a quick review of binary. We're used to dealing with the decimal system where we have 10 different digits, 0 through 9. And then if we want to go any higher than 9, we need another position. With binary, there are only 2 digits to choose from. There's the 0 and there's the 1. And if we want to go any higher, we need another position. So 1, 0 is 2, 1, 1 is 3, and then 4, we need another position. We've got 5 and 6. And you're going to start to memorize these. As a computer scientist, you're going to see this over and over. And then you'll memorize some of the common ones. So here's just 0 through 10. Now, what does this have to do with C? I talked about bitwise operators. What did I mean? Well, we've seen operands like addition, subtraction, multiplication, division, and the modulus. We've even seen a single ampersand when our scanf statements had an ampersand and a variable, and that was the address of operator. But that was a unary ampersand. This is a binary operator with an ampersand, something on the left and the right, and that means bitwise and. And the bitwise and is kind of like a logical and, but it's going to look at every single position of X and every single position of Y, and if there are any zeros on both X and Y, the bitwise and is going to result in a 0 in that position. If there's a 0 and a 1, there's going to be a 0 in that position for the bitwise and. A 1 and a 0, there's going to be a 0. Pretty much anytime there's anything other than a 1 and a 1, you're going to be left with a 0 with that bitwise and. Messing up my table. Okay, the next operator is our bitwise OR, and the bitwise OR just needs one and 1 or 2 ones to give you a true or a 1 answer in that position. So if we had both zeros in our X and Y, we'd get 0 as an answer. Otherwise, as long as there's at least 1, even 2 ones, you're going to get a 1 there in that position. And it'll do that for every single position in the answer. And then we've got one more binary operator on this slide, and that's the exclusive OR, where you want 1, 1, and 1, 0. So if they're both 1s, you're going to get a 0 as the answer. But as long as one was 1 and the other was 0, so I'm looking at the values of the X and the Y, 1's 1, 1's 0, so our answer for an exclusive OR would be a 1 in that position. Let me show you in a program and how you would apply that to a C program. Here I've got this little program with a single print statement that's printing the result of a bitwise AND with 3 and 2. So here I have in binary what this would look like. You'd probably really see a lot of extra zeros at the beginning because integers are represented as 4 bytes on most systems, and there's 8 bits in a byte. So there's going to be a lot of zeros, but these are the ones I want to concentrate on. And then if I'm looking at the 2 in binary, it would look like this. And if I do a bitwise AND, I'm looking at each column. So if you look at the 0 and the 0, well, neither one of those are 1, so that's going to be a 0. 0 and 0, you're going to see another 0. And my autocomplete's trying to fill this in for me because I've done it so many times. And a 1 and a 1, there's going to be a 1 in that position. And then finally, we'll have a 0 in the position because in the last position here, 1's 1, 1's 0, and you need both of them to be 1s for the bitwise and to result in a 1. So the answer is going to match that 2. So we run it and we're going to see a 2. Let's change one of the numbers and see. So we had a 3 and a 2. Let's make it a 4 and a 2. And this time, nothing's going to match up with a 1 in both of those columns. So our answer is just going to be 0. Let me change that to a 4. And yep, it is 0. But what if we try the bitwise OR? Well, the bitwise OR, you don't need a 1 in both positions. You only need a 1 in one position. So the answer, it's going to be a 0 and then a 1 and then a 1 and then a 1. And if you forget what that was 7. Okay, well, let's try the other one, the exclusive OR. So we need a 1 and a 0, but we don't want them both to be zeros. Why, that's going to be the same answer for this problem because there wasn't any position where we had 2 1s. But let's think of another example, like maybe 5 and the exclusive OR with our 4, and now that first column, since they're both 1s, that's going to switch to a 0, and our answer should just be 1. And it is. So what other bitwise operators should we learn about in C? Well, there's also the not operator, so just the single tilde. If you have a bit that's a 0, it's going to switch to a 1. If you have a bit that's a 1, it's going to switch to a 0. So for your whole number, you're going to have more than one bit. It's going to flip all of those bits. Other operators, there's a shift to the left and a shift to the right. So if I'm starting with an initial x value that is just 1 with all the zeros in front of it, and I say shift everything 1 position to the left, well, that ends up shifting that 1 position to the left, and it'll fill in whatever's revealed on the left with zeros. If I still start with that initial value of 1, but instead I was shifting everything 2 positions, then that 1 that was in our initial first position is going to move over 2 spots to the left. And if I had moved it 3, then we'd end up with the binary number 4. All right, what if we're shifting the other way? This time I'm going to start with my x value being 6 and shift it to the right. Well, if I shift it to the right, then I've got 3, because both of those 1s ended up shifting 1 position to the right. If I take my initial value of 6 and I had shifted them both 2 positions to the right, well, we've got a whole lot of zeros, and we lost one of the 1s. It was shifted past the boundary of our number, and then we just have 1 left as the answer. And if we were shifting it any farther to 3, we would just have 0. Everything's going to be 0. And we also have compound operators. You can do a shortcut assignment and bitwise and assignment and bitwise or assignment and exclusive or, and it would look the same as if you did the new x is equal to the old x with a bitwise and of whatever your number is. It doesn't have to be 3. I just picked 3. And here this would be saying the same as x is equal to the old x, bitwise or, and then whatever your other number is. And this is the same as saying x is equal to x. Let's see, that one was just a bitwise or. This one is an exclusive or with our